In this course, Seth Goldin will teach you how to Google like a pro. Knowing how to craft the perfect queries can make a huge impact on your efficiency and overall experience. Seth has been using Google to help him develop software for many years, and he's currently a CS student at Yale University.
Are you effective at searching the web? You access the internet every single day. After spending so much time searching, do you consider yourself to be a pro? Okay. Did you know that you can force Google to search exactly for a particular term by putting double quotes around a word or phrase? That quote is a search operator, and it's extremely powerful. Maybe you already knew that, but there's a lot more where that came from in this video. Searching is a skill not often taught in school or boot camps, yet many people, from programmers just getting started to senior engineers, heavily rely on it. If you're spending a third of your time researching information, that means a hefty chunk of your job is just being great with Google. I'd argue it's among the most important skills a programmer can bring to the table. But with millions of results to sift through, most people struggle to pick out the most relevant. The reality is, you're not always going to know everything. You will run into some bug you can't figure out. Maybe you decide to learn a new programming language or how to develop a feature. I guarantee you'll use search to find relevant documentation and articles and potentially to help understand them. Becoming better at search will make a massive difference in your productivity and efficiency, whether you're a software developer or not. And if you're an online learner, the number one reason why people fail to complete curricula, such as that available on freeCodeCamp, is because they get stuck and can't figure out their problem. The internet has almost all the answers, but you need to be able to extract them. In this video course, I'm going to explain how Google works underneath the hood. I'll discuss how to form the best queries, a fancy word for questions, and identify the best results. And I'm going to introduce you to around 30 to 40 search operators that will power up your searches to the next level. You'll learn to use these operators to augment your existing searches. And instead of randomly clicking on the first few of millions of results, you'll be able to search for fewer, higher quality answers. While the info in this video is focused on Google, as per the title, much of it will apply to other popular search engines such as Bing, DuckDuckGo, Baidu, Yahoo, Brave, Kagi, and more. I'm also going to touch on more specialized and alternative search options towards the end. This video does have a programming bent, but I'm going to try and keep it as approachable as possible. Even if it only offers you a couple new tools in your search arsenal, this video could have a massive impact on your work simply because of how much you use search. Stop being a passive web searcher. Let's get started. If you're watching this video, you probably use Google a lot. But that's pretty easy for me to predict. Everyone does. The average person makes 3 to 4 Google searches per day. As programmers, we're super users, often searching anywhere from 2 to 20 times that. I certainly fall into that camp personally. There are many awesome resources out there. Stack Overflow, Medium, Dev.to, and of course freeCodeCamp, which are accessible via a simple search. A common misconception is that you're searching the web. In reality, you're searching Google's index of the web. In many ways, Google is like the hub station that connects us to all the different parts of the internet where we hang out. For many people, that internet is Google and Facebook. I'm going to help you understand how Google search works behind the scenes. Knowing why some sites rank higher than others may help you more effectively find what you're looking for. If you're already familiar with how Google search works, or more interested in ways that you can phrase search queries, feel free to skip to the next part. Back in the 90s. The original algorithm that Google used to order web pages was known as PageRank. Developed in 1996 by the founders of Google, Sergey Brin and Larry Page, the concept is basically, what if we applied how citations work in academia to the entire internet? In the research world, the more citations a paper has, the more important and relevant it's considered to be. PageRank similarly theorized that many websites would link the most important pages, a concept called backlinks. It examines how many quality internal and external links a web page has to estimate its importance. If a lot of high-quality sites link to some new page, that page might be high quality too. When this algorithm was applied to a commercial search engine, which was originally called Backrub, it was able to surface results that were more useful to consumers. PageRank is actually public domain. Even if you're not familiar with some of the math, it's a pretty interesting read. While PageRank is still considered as a factor when ordering search results today, it's not quite the same as in the original paper. Plus, it's now in combination with several other stronger signals. So, how does this work today? Here's where your search results currently come from. First, Google crawls the web. That means it algorithmically discovers and compiles new and updated web pages into a massive internal database of millions and billions of sites. There's also a few ways search engines like Google can find a new web page, such as sending bots, also known as spiders, to visit them following links from known pages. People can also submit pages for Google to index, which is called using a sitemap. Google renders the web page during this process, which includes running JavaScript, in order to ensure that all content is visible and keep track of the information on each web page. Now that Google has this massive registry of information, they need to organize it somehow. The content in newly crawled web pages is analyzed and used for indexing. If you're familiar with web dev, this includes looking at hidden metadata, such as title tags in the HTML. Google then tries to filter out low-quality content. This is really important, as the reason you probably keep coming back to Google is because you find it reliably helpful. Search engines determine the quality of content through signals, which are thousands of characteristics of web pages that align with what humans might interpret as high quality or reliable. PageRank, which I discussed before, is one of those signals. Speed and web vitals are also strongly considered. Another is RankBrain, which uses AI to conduct semantic search, or make sense of the connections between links and content in web pages. Google stated that RankBrain learns to improve over time, and was at least at one point the third most important signal. There are also thousands of search quality raters who have the job of ensuring these signals are working as intended. After quality filtering, Google clusters web pages with similar information. One web page is selected to best represent each group of similar pages. This is what you see in the search results. Google's algorithm is still somewhat secret, in part because of the black box nature of AI, and in part to try and avoid people gaming the system. So, what happens when you search something? Whenever you enter a query, Google does its best to use some of the signals I discussed before and interpret what your search means. This can be tricky, as, like humans, search engines have difficulty in identifying things like tone from text alone. According to Google, it took 5 years to develop their system for spelling mistakes and synonym matching, but it's now used in around 30% of searches, so I'd say it's probably worth it. After Google has an idea of the meaning of your search, they then scan their database for the web pages they believe will be most relevant. Relevancy is influenced by literally hundreds of factors, such as your location and language. Because Google's registry is so massive, there will often be millions of results relevant to your search. Those pages are ranked programmatically based on their relevance and then served to you, usually in a few milliseconds. Let's say I search for science internships. Some information Google has on me from my last 3 months of usage. My location is at a university. I'm studying computer science. I read The Verge, TechCrunch, and FreeCodeCamp. And 3 of my most visited websites are GitHub, FreeCodeCamp, and Stack Overflow. Google is able to use this context in combination with my query, which is popular from my area, and determine that what I actually want to see information on is not science internships, but computer science internships. And you can actually test how this works from any location. Now that you have a better idea of how Google serves web pages, let's see how you can form better queries. Time to discuss the ultimate question for getting the most out of Google. What should you actually type in the search box? How can we take the inordinate number of results and filter them down to what you truly want? Be thoughtful. Searching efficiently is about finding the balance between concise and descriptive queries. Begin with something simple like, what is X, or how did Y? Depending on the results of your search, you can reformat your phrasing. Use what we learned about how Google works. Whenever you make a search, put yourself in the mindset of the person writing your answer. When rephrasing your question, consider what words might they include in the title or content of your ideal webpage. What synonyms or key phrases? For instance, don't search, I'm confused by when I should use semicolons. Instead, try when to use semicolons or semicolon grammar tips. Being more precise in your queries usually translates to more relevant results. Let's say you love to bake. How to bake the best apple pie returns 214 million results. A more specific search, such as best Dutch apple pie recipe, has under 8 million that are closer to what I'm craving. As a patient, you might search, what's the best place to treat heart disease? Where a more effective search could be best hospital for pediatric heart transplant. And if you're debugging, there's dozens of things you can try here. Still, it's possible to be too specific. Consider what you actually want to learn and avoid including redundant or unnecessary terms in your query. Let's say I need to know how to execute a piece of code when a widget loads in Flutter, for a loading screen, for example. Instead of searching Flutter async login widget, I can search Flutter async widget. While specifying loading might be more specific, it can also cause Google to return fewer quality examples of what I really want to know, which is the concept of asynchronous widgets in Flutter. Think about how complex your query is. Can you break it down into smaller questions? Try to distill the core issue of your search into the set of terms that you use. Google is often more effective when retrieving information for one question at a time. Watch your words. When choosing words to include in a query, there's a few things to keep in mind. First, every word is meaningful. A single word can make a massive impact on the results you receive. For example, dove, a dove, the dove, and Dove chocolate will all return very different results. In the last case, it's very clear you're searching for the chocolate brand, but even small words like a or the inform Google that you're not searching for the beauty products. To be safe, type words that commonly appear next to each other in the way that you'd expect to see them. French horn, not horn French. Spelling, punctuation, and capitalization do not matter. freeCodeCamp in all caps, and freeCodeCamp in snake case or title case all return the exact same results. Sergey Brin once said his goal was for Google to know what you're searching for before you do. We haven't yet fully reached that point, but it can certainly help you get a question from your head into the search bar a lot faster. Understanding how Google generates autocompletion can give you an idea of topics similar to what you're researching. It can help you complete your queries more quickly. Google states their autocomplete feature reduces overall typing by around 25%, which adds up to about 200 years worth of typing each day. Predictions are generated by comparing the characters that have been entered with what you've searched before and what other people in your region have searched. Google also has systems for predicting portions of a search rather than the entire query. Their autocomplete engine will automatically shift from one mode to the other. Let's say you're confused by the complex iOS app development pipeline. If you search tutorial for how to install Apple developer certificates, Google may help finish the second part of that phrase. As an extra tip, if you can't remember a word when using autocomplete, you can replace it with an underscore as a wildcard word. If you want to get more unbiased results, you can open up an incognito tab. In Chrome, that's accomplished with Control-Shift-N. This will log you out of all accounts and enable you to find results without the important influence of your personal search history. These tips will hopefully help you ask better questions, but even very specific searches can offer millions of results to sift through. In the next part, I'll discuss how you can pick out the most helpful ones. Throughout the rest of this video, I'm going to cover how to use keywords and operators to filter your results, techniques, features, keyboard shortcuts, etc. These will all help you obtain more helpful and relevant results. but ultimately, determining the most accurate and useful information is going to be up to you. Many people blindly trust the first 3 results will be best. The number 1 position on the results page gets a third of all traffic. But successful online research requires critical thinking. The first search result, the first Stack Overflow answer, those won't always be accurate or helpful. Let's examine the search results page, or SERP, the one with all the blue links. Each result on the search results page has a title, URL, and description, also known as the abstract snippet. As I mentioned before, these are ranked by relevance. Don't stop with the top result. Instead of randomly clicking on the first few links from the millions of results, try this. Look at the entire page and consider the context surrounding the question you had or the concept you're trying to learn. Remember what you previously thought your ideal search result would include in its title or content. Now, see if any of the results on the SERP match that info in their titles or descriptions. Reading results carefully is the most important part of this entire process. The descriptions of each result often have relevant bolded terms in them. If I search how to audit a class online, I'll see the top result has bolded auditing a course. If you see words you're unfamiliar with in a title or description, don't skip that result. You can open another tab and look up the definition, and then return to your research. Another essential tool that Google engineers recommend for finding an answer or getting a handle on a topic is called lateral browsing. When I'm researching a topic or debugging some code, I'll often control-click on several results at once. This will open them in new tabs for me to peruse, swapping between as needed to cross-reference content. When scanning through your search results, take note of top-level domain names, or TLDs. These are the highest level of abstraction for domain name systems, or the DNS, and noted as the ending of each domain name. TLDs are important as a way of gauging reputation, authenticity, or authority. In the United States, sites for educational institutions will commonly end with .edu. This is generally an easy way to identify more reputable sources. It also applies for other TLDs, such as .gov for government websites. You can often pick a website source based on their domain ending with a country code. For instance, sites based in Spain might end with ES, and sites in India often end with .in. Notably, you don't need to live in a country to use their country code as a domain ending. .io, meant to refer to sites in the British Indian Ocean Territory, has been heavily adopted by computer scientists because it can refer to input-output and because it sounds cool. Internationally, many TLDs combine a country code with endings such as .go.br or .co.in, which are the equivalent of .gov and .com domains, respectively. You may come across information while searching the web that you question. Some info can change significantly based on context. If you search for the number of programmers in the world, that number will change based on how the source defines a programmer. Don't accept that anything you read on the internet is authoritatively accurate. Google does their best to filter out bad actors, but stuff slips through the cracks. Additionally, even people with good intentions often make it difficult to verify their statements. If I said 73% of programmers go to bed before midnight, how can you best confirm that? Ideally, I'd have provided a source, but I didn't, so as far as you know, I just pulled that number out of my butt. Who's considered a programmer? Time zones exist, so midnight where? As an inquisitive person, you can start by conducting another search of your own, but take care to not include the answer in your query. That's an easy way to have confirmation bias. If you search for, are there 25 million programmers in the world? Chances are someone in the world has written down or recorded that statistic. You've found it on the web, but that doesn't mean the number is right. A search asking JavaScript is the most popular programming language is likely to pull up information saying that, yeah, people love JavaScript. Instead, try and write more general, open-ended queries like most popular programming language 2022 or how many programmers in the world. A fantastic way to verify information is to find several perspectives. If multiple credible sources agree on an answer, it's more likely to be correct. Check to see when content was written and where it's sourced from. Then, consider if that makes sense for the subject matter. For instance, an article about a quote attributed to a person who passed away, long before any references connecting the two on the web. Did you know that the famous line, "Luke, I am your father," is different when said in Star Wars? The line is actually, "No, I am your father." Simply searching "Luke, I am your father" will probably pull up this result, but you can go deeper by searching for the original script of The Empire Strikes Back. Reputable sources are really important. The new highly cited indicator that appears on sources that are being used as a reference for other news outlets is one feature that helps with this. Additionally, check if a site you've discovered in your research has any reviews, or if people have discussed it in forums like Reddit. Whenever you're reading information, ask yourself, why might this site not be reputable or trustworthy? While forums are incredibly useful, since anyone can post, take everything said on Stack Exchange sites and similar sources with a grain of salt. Wikipedia, though, is actually still a fantastic place to start a search, because there are usually dozens of curated citations related to your topic to view. One of the most important parts of thinking critically while searching the web is asking yourself effective questions. Is there evidence for this? Is it always the case? What's an alternative viewpoint? Also, ask yourself questions about those questions. Does that make sense? What assumptions do I make? Can I break this down into smaller questions? As humans, we're hardwired to dislike information that conflicts with our pre-existing beliefs. This is one of the trickier aspects of becoming a pro web searcher. You need to be willing to accept all answers from trustworthy sources with an open mind, even if it makes you feel uncomfortable. If you are feeling emotional about an answer, conduct another search to confirm its validity. But stay skeptical. If a piece of information seems sketchy, maybe it is. It can be worth it to see what conflicts of interest a source may have. If a site is backed by a politically motivated or extremist organization, it's likely that the authenticity of journalism of that source is compromised. Many sites also pretend to be affiliated with a reputable person or organization, so always assess whether what you're looking at is actually legitimate. An easy way to do that is to do another query. Searching "Who owns freeCodeCamp.org" will pull up the name Quincy Larson. By reading more about Quincy, perhaps by searching "Who is Quincy Larson," I can discover that he is a highly transparent and reputable person without major conflicts of interest. But wait, this video is published on freeCodeCamp's channel, which means that I could be biased when I said that. Although, I promise you anyone who knows Quincy will back me up that he's amazing. Still, it's important to verify that you can trust not only the platform information is published on, but individual authors as well. Be careful of ellipses in result descriptions. Sometimes sentences will be cut up in a way that's misleading. It's usually a good idea to validate an answer by clicking on the link and reading the original text. You can also click on the vertical ellipses next to a search result title to see Google's new About Source feature. This will give you information on why Google thought that that result might be relevant for you. Finally, keep in mind that a website's ranking on your search results page is not a reflection of its credibility. Nutty stuff can be listed as top results if they're relevant to your query. Similarly, anything that shows up as an ad has generally not been evaluated for accuracy by Google. Now that you're an expert at extracting and validating information from Google search results, I'm going to speak about some awesome operators that will power up your queries. Google has dozens of features called search operators to improve your searches. They're extremely powerful filters and utilities, mostly focused on helping you achieve much more specific and relevant results. You've probably used several without knowing. Some are keywords, others are special characters. They're mostly case insensitive, meaning it usually doesn't matter if you capitalize them or not, and all can be used anywhere in your query. Google is updating these on a regular basis, so the list might not be fully comprehensive at the time you're watching. I have personally tested them, so they should all work at the time of recording. Let's dive in. Any search term or phrase will refine results by attempting to find exact and similar matches by default. It will follow the steps I outline when discussing how Google works. If you don't want to remember or reference the following search operators every time that you conduct more advanced queries, you can visit google.com/advanced_search for a simple to use interface. First up, matching operators. Remember that first example I mentioned in this video? Using double quotes around any term will force Google to match it exactly. I find this to be among the most useful operators available. Let's say you have some specific word or phrase, such as an error code or a message you come across while debugging. Putting quotes around it will cause Google to more accurately find the right Stack Overflow post or GitHub discussion. For example, quote, Flutter, end quote, app development tutorials will only find app development tutorials specific to Flutter. You can also use double quotes to override spelling autocorrection. This is especially useful when you're dealing with names with unusual spelling, or those that are very close to extremely popular similar searches. For instance, if you search my name, Seth Goldin, you're probably going to get a full page of results for Seth Godin, the famous businessman and author. By specifying, quote, Seth Goldin, end quote, you'd be able to find my personal site and blog. You can also use this for specifying a particular author when searching articles. Learn from free courses Seth Goldin, in quotes, would filter by my name. Google will sometimes return results with a term or topic that you don't want. It happens. The minus operator, or exclusion operator, when used preceding a word, will filter out any results containing that word. This is awesome. You can use it to easily get rid of all those pesky words that invade your search results. Because let's say you search for website tutorial, but you don't want it to include the framework jQuery. You can search website tutorial minus jQuery and exclude jQuery from your results. Sometimes you just need a wildcard. The asterisk operator, like a diamond Scrabble tile, can be used as a stand-in for literally any word or phrase. I often use it to replace words that I've forgotten, I can't remember how to spell, or generally to speed up a search. Linus *Linux will return results on Linus Torvalds, the creator of Git and Linux, more quickly than if I spelled out his name, given that I provided appropriate context. I find the wildcard operators particularly useful, though, when debugging. Often, the error message that I'm given contains a local directory that will only be relevant to me. Instead of pasting that whole block of text into Google, replacing that section of the error with an asterisk can significantly improve results. This can also be helpful when trying to find relevant walkthroughs for confusing homework questions. Often, we deal with words that have multiple meanings, but are used in dramatically different contexts. A BlackBerry is both a fruit and a cell phone. A transistor is a processing unit and a fantastic video game. Searching by a word's proximity to another word using a round and then a variable number is a highly effective way to narrow results, especially when the two words don't often appear right next to each other. If Google can't find any examples of the two words around each other, it's going to revert to ranking as normal. Let's say you're looking for a tutorial on managing memory in computer environments. Manage around for memory is likely to narrow in on those particular results by finding any web page containing an instance of the word manage within 4 words of the word memory. Football around 6 ESL will similarly help me fuzzy search for specifically European football instead of the American football results that I would normally see. Notably, this particular operator must be capitalized to function properly. Next up, date operators. Whether it's finding recent Stack Overflow answers or reading a review from the time a movie was released, I constantly want results from before or after a specific date. You can accomplish this with the before and after operators. Simply follow either with a date in the format year, month, day, append it to your query, and you're set. For example, an error message after 2021-01-01 will only return results since January 1st, 2021, meaning that I won't have to sit through outdated answers. You can also choose to only pass a year, such as before 2020 or after 2017. Python courses after 2021 would only give you recent courses so that you can be confident that everything's up to date. But wait, I have a start and an end date in mind. Well, there's 2 ways you can approach that. You can include both a before and after operator in your query, or you can use the range operator, ellipses. You can find info and documentation for a less common programming language such as with Clojure, 2016 ... 2018. You don't just have to use this for dates. Any numbers will work. For example, top 7 ... 10 facts, Apple computers will find a top 10 list or a top 7 list. The ellipses operator can be a little finicky though, so don't expect this one to work 100% of the time. Next up, source operators. Google provides several options to filter by content type and source. Some people joke that Google is a better search engine for Reddit than Reddit. Amusingly enough, I have found this to be often true. Many sites have periodically ineffective internal search engines, including hugely popular ones such as Amazon. I also find that sites like Reddit and similar forums can have more trustworthy human responses to my questions than the average first search result, so I often choose to filter my results by these sites accordingly. Cite is extraordinarily powerful because it allows you to force Google to only return results from a particular website. Appending cite:/freeCodeCamp.org to a query will only return results from freeCodeCamp. Importantly, you can also use sites with the top-level domain endings, or TLDs, that I discussed earlier in this video. Cite.edu will restrict your results to purely educational resources, such as with berkeley.edu or yale.edu. Search, followed by a website URL, accomplishes the same thing in most browsers, but I prefer Cite URL because it's shorter. On occasion, you'll need to search for PDFs, PowerPoints, or other documents on the web. To force Google to only display results that match a particular file extension, you can use ext or file type, which are functionally identical. Simply follow either with an extension such as txt, pdf, docs, ppt, xlxs, csv, epub, etc. in the format file type: pdf. I find this operator is super useful in searching for textbooks, academic papers, novels, presentations, and especially anything when relating to academic research. Unfortunately, file type no longer works for MP3 files. If you prefer to search the web for news rather than follow 400 RSS feeds like me, the source operator is a great way to specify the site that Google News should pull from. For instance, Amazon, source, TechCrunch, or source, The Verge, GitHub. Your search results can be extremely different based on your location. While Google tries to use your current location by default, it's possible that you'll want to specify somewhere else. San Francisco will change my results to be more relevant to the Bay Area, even if I'm searching from the East Coast. I'm a fan of blogging and reading other people's blogs. It's often a more personal and conversational experience about niche topics of your interest. While Substack and similar providers have consolidated a lot of bloggers, many websites and companies still run their own blogs. You can find these through the blog URL operator, which attempts to find any blog posts under a domain. Blog URL, google.com, will pull out the blogs under Google's registrar. It can be a little finicky sometimes, though. No website is ever able to escape going down every so often. You can utilize the cache operator to pull Google's cached or backup saved version of any website. For example, I can see all of freeCodeCamp's articles, even if the site is down, by typing cache, freeCodeCamp.org. Next up, Boolean operators. Google automatically tries to include all the content within your query. So AND is best utilized in combination with other operators since it doesn't do anything by itself. I'll discuss combining operators in more detail later. As I just noted, Google searches default to including everything in your query. The OR operator is unique from other operators as it causes Google to alter that behavior and increase the number of search results rather than filtering some out. Using the pipe operator, or A or B, you can scan for A or B. You'll get results related to A or B or, importantly, both. If I'm interested in multiple variants of a data science algorithm, I can conduct a search on k-means or k-means++ to return any result that refers to either. The OR operator is also useful when searching for something that's known by several names. In the American Civil War, the Union soldiers referred to a conflict that took place in Virginia as the Battle of Bull Run, but the Confederate soldiers kept their records based on waterways, and in their records, they called it the Battle of Manassas. When searching about this topic, Battle of Bull Run and Battle of Manassas Each returns significantly less information than Battle of Bull Run or Battle of Manassas. As I noted before, make sure you capitalize or Google might not recognize it as an operator. Next up, the in operators. These operators can be used to massively narrow your search results based on the content included in web page metadata. If you're unfamiliar with web dev, by metadata I mean the URL or website link, and internal information such as the page title, content, and anchors. Each of these operators has two versions, an in option and an all-in option. The results for both will be similar, but all-in will only return results containing all of the following terms. They both help to ensure that the words you're looking for will actually be present on the pages returned as results. Websites will often put important information in the URL of web pages. You can use in-URL tutorial to only return tutorials, or all-in-URL tutorial Python app for more specificity. Remember how the file type operator no longer works for filtering out MP3 files? You can actually use the in-URL operator as a substitute, such as searching for lo-fi in-URL MP3. The title of a web page is one of the best ways to tell how relevant it will be to you. In title, Flutter will only return websites that refer to Flutter, while all in title, Flutter app tutorial will have fewer hits. The keyword you're looking for isn't always included in the title or URL. In those cases, in text and all in text will have more benefit. Anchors are often invisible, linkable section headers of web pages. They're usually indicated by hashtags such as #hero or #testimonials. In-anchor and all-in-anchor will help you identify web pages with such tags. Notably, these inclusion search operators are often best used in combination with each other. They help you extract web pages that might not have been surfaced otherwise. Finally, Google provides many utility operators that you can use to quickly access all kinds of data. I use these all the time. Wondering what a word means? Define, and then the word, will tell you using Google's built-in dictionary. It'll likely display in a side panel, along with synonyms. Define, entrepreneurship, will quickly pull up the definition, and you don't even need to be able to spell the word properly. Related is one of the more interesting operators that Google offers. It returns websites that are similar to the following domain in the format related, : and then the web page URL. It's useful for breadth of research, particularly when trying to learn something. For instance, related, freeCodeCamp.org will return sites like codeacademy.org, coursera.org, etc. Need to check your public IP address? The unique identifier that allows your computer to receive information? Just enter IP address, and Google can display what it identifies as your public internet protocol. Do you know how many pounds are in a kilogram off the top of your head? Or how to convert from Fahrenheit to Celsius? Or how many milliliters are in a quart? By using the format X in Y, Google can swiftly tell you. For example, $456 in euros will tell me that $456 is, at the time of recording, $434.45 in euros. Online shopping is huge right now. Chances are you probably search Google to see different places that offer your item of interest. If you're looking for a specific price, you can search $300 with the $sign, Android, and Google will attempt to match that. You can also apply the range operator here and search keyboard $10 ... $50. Looking for a social media account of a friend or content creator? Instead of searching their name, prepend an @ symbol to their social media handle to more effectively pull up all their social accounts. Want to immediately know the weather for any location? You can just search the word weather for your location, but to specify others, append the location like weather, : Bangkok. While you might use apps like Google or Apple Maps or Waze for your mapping needs, sometimes you'll need to search for one. While it returns the current location by default, you can specify a particular location like map : London. There's a new movie out and you want to go see it. While searching the movie title is usually enough to pull it up, If it's based on a book or something similar, your search might not pull up exactly what you want. Using movie, Avengers Endgame, is then a foolproof way to get a lot of info about any film, including reviews, cast and crew, and nearby showtimes. Fintech person? You can see all the stonks for any ticker by searching stocks, and then the appropriate ticker, such as stocks, Amazon, for immediate information about the price history of Amazon. There are several other tools you can access straight from Google's search bar. If you type any math equation, Google will automatically calculate the answer. If you ever need an on-demand clock, type timer or stopwatch to pull one up, or type X minute timer to automatically start one. Search for flip a coin or roll a die when you need to cast a stitch in time, or any other situation when generating a probability is necessary. You can also pull up a quick reference tip calculator with Tip Calculator. This calculator feature can also be useful for very important factoids like the number of horns on a unicorn and the probability of once in a blue moon. Together, you can use these utilities to more quickly access everyday information. While they may not be as essential in the software world, they're still going to help you make better searches in your day-to-day life. These are a lot of tools that you can utilize to filter your searches, and operators become even more powerful when you're able to combine them effectively. For example, how to build an *app site freeCodeCamp.org minus Flutter will give me results on any kind of app tutorial except Flutter on freeCodeCamp containing the name Quincy Larson. Another helpful combination could include the site and URL and exclusion operators. You can search site freeCodeCamp.org minus in URL blog to get all the subdomains except blogs, or you can find insecure pages on a website using site domainname.com, where you fill in the appropriate domain name, minus in URL HTTPS. I find combining the wildcard and exact match operators to be very useful. Quote, Python, tutorial, end quote, will return any results with Python and tutorial, in that order with anything in between. For example, Python app tutorial. The wildcard operator is also very easy to include with other operators such as site and in URL. You can use parentheses to power up your combinations of operators. I commonly use these when grouping for order of operations with Boolean operators like or when using synonyms. If I want to specify a bunch of synonyms when searching for a resume, I can do that. Keep in mind that the pipe operator or operator are functionally identical. Google processes and or operators in a logical order. Make sure to use parentheses when necessary. For instance, Python and parenthesis, JavaScript or TypeScript parenthesis will be interpreted as looking for results including Python and either JavaScript or TypeScript. Alternatively, Python and JavaScript or TypeScript will return results with Python and JavaScript or results with just TypeScript, not in any way related to Python. Let's say I'm looking for tutorials on the language closure. By linking together search operators, I'm able to form a query which gives me only about 100 highly focused results. There are a practically endless number of combinations of search operators. I encourage you to consider what will be most beneficial for your search and mix and match accordingly. Next few parts, I'm going to discuss several features, specialized search options, and search-related tools that you might find helpful. Since you've used Google, you're familiar with how to search for images. Just type in some keywords, click on the Images tab, and voila! But what if you already have the image or in front of it, and you need to figure out what it is or where it's from? Google Image Search and Google Lens are two powerful tools to accomplish that. You can access reverse image search by clicking the camera icon or visiting images.google.com. Upload or drag your image into the search bar and it will scan the web for images that look similar. For instance, I have this image of some phones on a yellow background that I pulled off of Unsplash and used in a blog post. I can upload it to reverse image search and see all the other websites that are using it as part of their articles. These include 5 ways the original iPhone was ahead of its time, Apple now has 1 billion active iPhones around the world, and these are the top 4 highest selling iPhones of all time. I can also filter for other sizes of the image and photos that are similar. Plus, you can use the color drop-down menu under search tools to filter photos by color, transparency, picture size, and animation effect to find that perfect GIF. This also works for faces, clip art, and line drawings. Reverse image search is useful if you already have a photo and you're sitting at a computer. But what if there's something right in front of you that you want to learn about? Perhaps a product you'd like to find online or a location you're at. Google Lens is an awesome, relatively new feature which debuted in 2017 and identifies objects in your camera lens in real time. Here, I'm using it to take a picture of my desktop speakers. Google Lens quickly identifies their Logitech speakers and pulls up search results of their pricing and availability. You can use Google Lens to search for homework help or excerpts of books online and copy text from physical documents, similar to Apple's live text feature. I'm a particular fan of their real-time translate function. I can point my camera at a menu in a foreign language and receive a version in my preferred language. These image search options may be more helpful in your daily life than for software development, but they're incredibly useful tools to have in your search arsenal. Everything that Google indexes is known as the visible web, but sometimes you need to delve deeper. This is usually because of the long tail. Many people treat Google as the all-encompassing internet. If you can't find it on Google, it simply does not exist. But that's not entirely the case. Before anything else, make sure the reason you're not seeing any results isn't just what you searched. A lot of times, the issue is information retrieval, not the indexing of the information in the first place. If you have a hyper-specific query, every word that you've added makes it more likely that you've excluded results. Try broadening your search, and it's possible that what you're looking for will pop up. While Google tries their best to index everything that can be useful, the web is a large and complex place. In Google's best efforts to fight spam, content can be missed that may be important in more niche scenarios, seen in things like their indexing of large websites with too many subdirectories or subdomains. In attempting to cut back on duplicate content, Google has, in some cases, completely wiped content off their SERPs. Sites like GitHub are offenders here, where some repositories can no longer be found on Google because they're old or unused. But while Google's better than ever for the majority of searches, in niche cases when there's less data to work with, you could even find nothing. In these cases, you'll want to consider trying alternative search options that specialize in the area that you're looking for. Google actually provides a few of its own for more niche areas. Google Scholar is a massive collection of scholarly literature from the global scientific community, and it is an amazing resource for serious research. It is primarily made up of papers published in respected journals spanning everything from biology to neuroscience to machine learning and natural language processing to legal opinions. It also includes scholarly sites and content from universities. Scholar is particularly useful when conducting more thorough research on an academic topic, with some major perks over traditional search. To start, it provides links that direct to the full version of scholarly articles, books, and reports. Scholar enables you to see the number of citations papers have, where they're published, and any related authors or affiliated institutions. It also has built-in options to copy citations and export bibliographies in formal MOA, APA, BibTeX format. You can even dive deeper into individual authors and view their aggregate work. It's similar to other academic search engines such as Papers with Code, Web of Science, and Scopus. While the process of entering a query is the same as with normal search, the results page is a little bit different. If I search natural language processing, you can see that the result blocks now each contain bibliographic info. This includes the title of the article, the source, the author, or authors, when it was published, and who it was published by. Some results will even have options to see the abstract or even download the full document as a PDF. The version you see in Google Scholar may not always be the final paper. Google does its best to show the newest freely available version, which often means a preprint. Adding a year or restricting by a date range in your search can be very useful in getting more recent findings. Try and make use of some of the operators we discussed before, including and, or, exclusion, and exact match operators. For instance, neuroscience author, quote, Seth Goldin, end quote, 2022, will pull up my recent paper on analyzing EM images. Or, quote, machine learning, end quote, minus medicine minus biology, will return results or ML papers that don't have it to do with those subareas. Google Scholar is not infallible. Citation data is often not fully comprehensive or up to date. Using the verification skills that I discussed earlier, try to check out the original publisher as well to check your findings. Google also supports a powerful patent search available at patents.google.com. You can search Google Patent Search or Google Patents Advanced Search on Google for more options and filters. Using this tool, you can find information on patents searching by title, number, inventor, signee, and more. Google currently keeps track of patents in North America, Europe, and Japan. It's a great resource for anyone researching patent information, which may not be readily available in a general search. If you're unfamiliar with common browser keybinds, I'll share a few. These are generally the same across all browsers and massively increase productivity. Replace Control with Command and Alt with Option if you're using Mac OS. As I mentioned in Part 3, Control-click opens a link in a new tab. Control-T opens a new tab. Control-W closes the current tab. Control-Shift-F or Alt-F focuses the search bar. Control-R refreshes the page. Control-Alt-R hard refreshes the page from origin. And Control-F searches for text within a web page. This last one is super critical to efficient searching. I constantly use Control-F to find the content that I'm seeking on a web page. It saves tons of time that I'd otherwise spend skimming information that's potentially unrelated to what I'm looking for. Knowing these keyboard shortcuts will hopefully help you navigate the browser and complete searches faster. Congrats! You're now all powered up and ready to go and get the most out of Google. That puts you ahead of most of the other 27 million developers in the world. Was that statistic real? Try and search for yourself. I encourage you to consider how you can combine everything that I've discussed in this video to obtain the best answer to your question. Start with a simple search. Use specific terms to narrow focus, but avoid unnecessary or redundant terms. Put yourself in the mindset of the person writing your answer. Break down multi-part queries into several searches. Verify your results. Browse laterally. Use search operators and take advantage of specialized search engines. Searches will sometimes be simple. Other times, you'll be deep in the weeds. Online detective work can be hard. My last and most important piece of advice, don't give up. It might take 2 searches, or 3, or 6. Rephrase your query and try again. You have access to all of human knowledge. Take advantage of it. Thank you for listening to this video course. I hope it was of some help to you. After finishing this course, do you feel like you'll approach search differently? I want to thank the amazing people at freeCodeCamp who supported the development of this course. Additionally, my appreciation goes out to Google search intern Eric Bozen, Lincoln Baxter, and several Google engineers who requested their names remain private for reviewing the course material and helping me make it the best possible. That's all, folks!